Friends, previously we studied what is meant by vector, scalar, and how to represent a vector, and what is meant by the position vector of a point with respect to the origin. And also we know about some vector types also. Okay. Now in this video we learn about another thing. It is that the algebra of the vectors. Okay. In algebra of vector we are going to study basically the sum or means I can write this as addition. Okay, addition or subtraction, addition or subtraction of the vectors. Second thing, multiplication of a vector by a scalar, and we are going to study also the vector components, So basically we are going to study these three main topics in the vector algebra of the vectors. Okay, so let us start with the addition and subtraction of the vectors. Okay. Yes, well, so basically we know that to add any two real numbers, it is very easy. To add any two integers, it is also very easy. Add any two rational numbers, no problem at all. But in the case of vector addition or subtraction, it is not so easy also, it is not so complicated also. Yes, so because of that, the vector is not consisting only the magnitude, it is consisting with the direction also. Okay, so because of that direction, we are going to study the two cases of the addition or subtraction. Okay, so what are the two cases? So let us, so case number one, so if suppose I say that, so case number one and case number two here. Yes, what is the case number one? So case number one is that the vectors are traveling in the same direction. The vectors are traveling in the same direction or opposite in direction. Okay, so what is in this case, how to add the vectors, how to subtract the vector. Or in another case we have the vectors are traveling in a different direction. So means basically we need to study these two cases under the addition and subtraction. So what is meant by addition and subtraction of the vectors means we are having a new vector which is called the resultant vectors by addition of the two vectors or two or more vectors. Okay, and this phenomenon, this process is known to be as the composition of the vector cities. What is that? The composition of the vector cities. So means the process of getting the new vector which is called the resultant vector is known to be as the composition of the vectors. Yes, and here to add or subtract we have two cases. One is same or opposite direction, and another thing is in the different directions our vectors are traveling. Yes, okay. So now I will provide an example for the same or opposite direction. Suppose a vector, for example, this is AB vector, A, B vector of 5 units. Okay, and another vector BC, BC vector of 3 units. Yes, so means AB vector is traveling in this direction which has a magnitude of 5 units. Okay, and BC vector is another vector which is also traveling in the direction of AB also. So means what is the case? The vectors are traveling in the same direction and having different magnitudes. Okay, so now addition of these two vectors what? So means we are going to be add here the magnitude of these two vectors here. So means what happens? The new vector will be formed by the magnitude of 8 units. Yes, so this will be A, C vector it is. So look, A, C vector. So C is where? Here we have. Okay, so means how we are going to add here? By joining the terminal point of this vector, AB vector, with the initial point of this vector here. So when these 2 points are joined, then we can have the new vector A, C vector. So means here what we do? We are adding the magnitude 3 plus 5. It is 8 units. Yes, so definitely there will be increase in the length of the outcoming vector, which is called the resultant vector. Okay, so means the vectors are traveling in the same direction. We are going to be add in this way. Yes, so and now another case. So supposedly this is the vector AB we have. Okay, A, B vector of say the 5 units. I will take the same example right here. So 5 units, and second vector I will consider B. I will consider this vector as in this way. So it is B, C of 3 units. Yes. So now addition of these two vectors means what? We are adding the magnitudes of both the vectors here. Both the vectors, and now the resultant vector is what? So this will be become as in this way. So mean this will be the vector in this way. So this is what the vector A to C vector. So which is of 2 units. Which is of 2 units. But I think your answer should be an 8 units. But it is not the 8 units. Because of why? This vector is going in this direction and this vector is going in this direction. Definitely. And what happened? This and this are both are opposite. So means opposite means one vector will be in the negative. So means what happened? So 5 plus this vector will be traveling in negative, means it has a negative side. So that's why it will be become as an true here. So means we have here subtraction of the vectors also. So means under the addition of the vectors we are going to be studying the subtraction of the vector also. So this is what how to be add when the vectors are in the same direction or in the opposite direction. Hopefully you are understood. Yes. So if you want to be as a well, so let us move on to the next topic. So means if suppose the vectors are traveling in a different direction, how to add them and how to subtract them. Okay. So now let us study. So now, so what is the concept? So vectors are traveling in different direction. Different direction. Okay. And in this case, so in this case, we are going to study some another 2 sub cases for the vector addition and vector subtraction. So for that, we have one case, the triangle law of addition, and another is the parallelogram law of addition. Okay, so mainly these 2 laws are we are going to study now under the case of different direction. So means the vectors are traveling in different direction. Then we are going to be use these 2 laws here. So means what? The vectors are traveling in different direction means they are definitely they are in free direction only. So they are called as free vectors only. Okay. So let us move on. What is meant by triangle law of addition here? Okay. So let us start. Yes. Yes. So supposedly look at this. If a vector A is like this, so AB is the vector. I will write here. This is what the AB vector, which is traveling in this direction, and another vector is here. So this is the what the BC is the vector. We will call this as a vector B. So addition of these 2 vectors, how to draw? So means by joining the initial point of this vector and terminal point of this vector here. So means I will write here. So means look. So this is what the AB vector here we have. So A, this is vector B, and I will draw the parallel to this vector here by joining. So means just in this way. So this is what the vector here we have BC. Okay. So now what? The addition means it is providing the new vector, isn't it? That the resultant vector. So that resultant vector is at here only. So this is what the resultant vector is. Yes, so okay, so this is what exactly the resultant vector of these two vectors. Yes, and now look, this looks as an what? The triangle only. So that's why this law is called the triangle law of addition here. Okay, so now here look, the AB is traveling in this direction, BC is traveling in this direction. So mean these two are traveling in the same direction only. But this vector is traveling in this direction. So mean this will be act as a vector A plus vector B here. Okay, so means we can able to state, we can provide a statement to this diagram or this law. So what is the law is, if suppose the two vectors are acting along the two sides of a triangle, taken in one order, so means taken in same direction, then their resultant is acting, the resultant is means these two vector resultant is acting on the third side of a vector taken in a reverse order. So means this will be acting this side, so means it will be reverse direction here. Okay, so means what is the statement? If the two vectors are acting along the two sides of a triangle, then the resultant vector is acting along the third side of a vector taken in another order. Okay, so this is what the triangle law of addition is. Okay, so now you can ask me one question. So if you draw this vector exactly parallel to this vector which are traveling in the same direction, so what happened? This vector A is dead opposite to this vector. Okay, sir. So look, if I take this vector as this AB, so this is what the AB vector. Okay, so I will draw the parallel vector of this. How? So look, this is what the parallel vector. Okay, so that the parallel vector to that, so means which is in this direction. Okay, so means this is in this direction, means this is in this direction. So what happens? This will be takes as a negative sign. Yes, therefore their resultant vector, look, this will become as their resultant vector. So this will be act in this direction. So this is in this direction, this is in this direction. Yes, these two are vectors in one same direction and this is in the opposite direction here. So this will become as an A plus or minus B. Okay, otherwise I write A vector minus B vector. So mean this would be state the subtraction of the vector, they are in the free directions. They are in the free direction. Okay, so this is what the addition of the vectors and this is what the subtraction of the vector, how it takes in the triangle law of addition of the vector. Okay, so if you want to take down these diagrams, so please note down it and try to understand the revision. Well, so move on the next type, the parallelogram law of addition here. So we are studying here the different directions of the vector additions. Okay, so now here look at what the law is stated. If the two vectors are acting along the two adjacent sides of a parallelogram drawn from a point, then their resultant vector is acting along the diagonal of the parallelogram drawn from the same point here. Okay, so this is what the statement. So let us understand this statement by the diagram graphically. Okay, so now look at here. The two vectors acting along the two adjacent sides of a parallelogram, drawn from the point. This is the point. Drawn from the point. Then their resultant vector is acting along the diagonal. Okay, so diagonal of the parallelogram drawn from the same point. Yes, so this will be stated A plus B, addition of the vector. But how it is stated, I will conclude it. So look at the diagram. So this OC is the diagonal and it divides the parallelogram into what? The triangles. Definitely, if I say this is what the vector B traveling in this direction, and we know that the parallelogram consisting two opposite sides are same and equal here. So means this is what the same direction, definitely this will be also the vector of B of the same direction also. Okay, so now observe. If you remove this thing, so only observe this here means what happened? This will be become as a triangle only. Yes, so that's why vector AB and vector B. This is OA and AC vector. So both are what? They are acting along the two sides of a triangle. So therefore, this will be what? The third side of a triangle, and it is the stated by the triangle of the vector only. So means the triangle of vector is also applicated in the parallelogram law of addition here. So means this is what the parallelogram law of vector additions, they are traveling in the totally different direction. Okay, so note of this point and note of the diagram also. So how it is the compounded. Okay, so let us move on. What are the properties of addition of the vectors? Yes, so let us move on. Yes, so let us move that. So what is the next thing? The properties of the vectors. The properties of vector addition. Properties of vector addition. The first property number 1. So if A and B are any two vectors, I can write vector A plus vector B is equal to B, vector B plus vector A. So this is the first property of the addition of the vectors. So means what happened? If the A plus B is equals to B plus A, so means vector addition A is the commutative law it is. Okay, so remember this thing. And the second thing is vector A plus B plus C, vector of vector A plus B plus C vector. So means the vector addition is holds also the associative law. So this is what the commutative law here. This is the commutative law. This is what the associative law. Yes, and I will tell you another thing. Vector A plus 0 vector is equal to B, 0 vector plus A equal to B vector A. So means this is what the identity law it is. Identity. So means where 0 is called the additive, 0 vector is called the additive vector, additive identity vector of this vector A. Okay, and similarly we have vector A plus minus of vector A is equal to B minus A vector plus vector A is equal to be what? It is what? The 0 vector. So mean this is what the inverse law of addition here. Law of right here inverse law it is, and this is identity. This is what? The identity law. So in this case we are define another law also, vector A into bracket B plus C vector. So means it is vector A dot B plus vector A dot vector C. So this is what the distributive law it is. Distributive law it is. So mean these are the main properties of the vector addition. Similarly, this vector also depends on the subtraction also. And now here we have another inequality for the vector. The vector A plus vector B. So means magnitude of vector A and vector B is less than or equal to magnitude of A plus magnitude of B. So this is what the vector inequality we can say here. Okay. Another thing of the vector is vector A, magnitude of vector A and magnitude of vector B is greater than or equal to B magnitude of vector A. Right here. So look, so magnitude of vector A plus magnitude of magnitude. So means this is case for the vectors are in the like vectors. So like vector, and this is for unlike vectors. So like vectors and unlike vectors. So like vectors का मतलब इतना है कि they are traveling in the same direction, and unlike vectors are traveling in the opposite direction. Okay, so these are the properties of the vector addition also. Yes, so please note down these points and let us move on. The next thing is in the algebra of vectors, the scalar multiplication of a vector. Okay, so let us move on. So move on another vector algebra. So it is multiplication of a vector by a scalar. Okay, so now so what is the definition says here? So definition of the multiplication of the vector by the scalar, it is, let A is any vector and M is a scalar. M is a scalar and we are not decided here M is a positive or M is the negative here. Just we are taken here what? M is just a scalar quantity, and the vector multiplication by a scalar is represented by this is M into vector A here. Okay, so this is what the definition of the multiplication of the vector by a scalar. Yes, and now so discuss some properties of this scalar multiplication with the vector. So what is that properties? Suppose if M is positive, so M is positive, then what happened? There should be the if A is a vector and it is traveling in this direction. So look, A is a vector and it is traveling in this direction, and we are multiplying M into 0. So what happened? The M into A should be in the same direction, whatever in the direction of A, and definitely there will be slight increment in the length of the resultant vector. Because of M is the scalar quantity, we are multiplying the M with vector, means we are multiplying with the magnitude of the vector A here. Okay, so that's why its magnitude will be going to be increased some instance. Okay, and second thing, if M is less than 0, M is less than 0 and vector is in this direction, we are taken here, and M is less than 0 means M is the negative quantity. So what happened? The multiplication. So multiplication of the vector by a scalar which is negative, then definitely there should be change of the direction should be happen. So this will become in this direction and some length should be increased at here. Okay, so let us take some examples. Suppose M is equal to 2. M is equal to 2. So what happened? This is what the vector, and M equal to 2 means it has a magnitude, and multiplying magnitude with by 2 here. So definitely, so it is what it is in this direction, because M is positive here. Yes, so there should be the increment. There should be increment in the magnitude also. So means magnitude means length of the vector. So it means this is what the length, and just incremented by 2 units here. So means this is what 2 into vector A here. Yes, so M is equal to be 1 by 2, half of the vector. So this is what the vector we have. Yes, so means half of the vector means half of this value. So means what happens? This should be half of the vector A here. So means magnitude of this vector is reduced here. Okay, if suppose M is equal to be minus 3, M equal to minus 3. So at that time what happened? So means is this vector traveling in this direction, and definitely the vector should be what it is of minus 3A of the vector, and it is in the direction of the opposite to the original direction. Okay, so these are some properties related with the multiplication of the vector by a scalar. So remember this property, and this property are useful to your examples. Okay, so remember this and note down these points. Yes, thank you. Well, so discuss some properties, okay, about vector algebra only. So consider, let us start the discussion. Okay, so let us consider point A and B. There are 2 points A and B, and this is what we have O, and I will join OA and OB. So this is represent the position vector of the point O with respect to the A. So means OA what? So OA is equal to the vector A and OB is vector B. So means OB is vector B here. Okay. So now look at here. So A and B are the position vectors of the point A and B with respect to the origin respectively. Okay. And we have 2 points here, A and B. So what will be the vector? What will be the vector which is joining these 2 points? Okay. What will be the vector which is joining these 2 points? So how we are going to represent the vector which is joining the 2 points AB? Yes, and which is given by the AB vector. AB vector is equal to be vector B minus of vector A. So means what? The position vector of the point B minus the position vector of the point A. Okay. So this is how we are going to represent the vector joining the 2 points here. Okay. But how it is came? So let us understand it. So look at here. Can you imagine OAB represents a triangle? Can you imagine that here in this diagram? Definitely. And this is one of the. Yes. And now look, if I apply a triangle law at here, so what happens? So this vector is traveling in this direction, and this vector is traveling in this direction. So means what? OA and AB vector. These two are traveling in the same direction, and OB will be traveling in opposite direction to that of A and that of this AB vector. Okay. So means I can say that OB vector is equal to be OA vector plus AB vector. Yes. So what is the statement of triangle law? If the two vectors are acting along the two sides of a triangle taken in one order, then the resultant vector is acting the third side of a triangle taken in reverse order. Okay, so means this is what the OB is the resultant vector of this triangle. Yes, and OA plus OB is provided the vector addition. Therefore, we get AB. So means AB vector is equal to what? AB vector is OB vector minus OA vector. Okay, so means what happens? This is vector B minus vector A. So means AB vector is represented by this here. So remember, always the vector joining the 2 points is always represented by B vector minus A vector. So this is called the position vector with respect to the 2 points here. Okay, so means this provides the position vector of the AB here. So remember this thing. Yes. So now let us move on another discussion. Suppose if I consider vector A. Vector A is equal to be A1I, A2J plus A3J, and vector B is B1I and B2J and B3K. So this is what the representation of the vector in terms of vector component. Okay. Now what happens? This AB will be how to write? AB is equal to what? B minus A. Otherwise, I will discuss some addition property. And vector A plus vector B. So A plus B vector means adding the vector components. Means what? Adding the scalar components of the similar vectors. Components. Okay. So means A1 plus B1 into I plus A2 plus B2 into J plus A3 plus B3 into K here. So how? This is what the addition. If I talk about the subtraction, what happens is the subtraction will be taken in this way. Okay, and now if I suppose K is any scalar quantity, and if I multiply K into A, if I consider K into A, so what will be happen? So this K into A will be represented K into bracket A1I plus A2J plus A3K here. So means it is K into A1 plus K into A2 j, sorry, here I, and k into A3 k. Okay, so means what happened when you multiply a constant, a scalar with the vector, it is multiplying with the vector components of individual, and it is multiplied with the scalar component of the I, j and k here. So how this is what the multiplication of a scalar with a vector here. Okay, so remember these 2 points. And now come at here, we have here b minus a. So b minus a means, how to write this b minus a? Just this b minus a means this will be provided. So I will write here. So look, this will become b1 minus a1 into bracket I plus b2 minus b2 minus a2 into j plus and b3 minus a3 into k. Yes, so this is what the vector will be represented by in 2 points. But this is what the vector represented in 2 points. So what will be its magnitude? Magnitude क्या होगा अभी? So means magnitude will be represented. Okay. So this is vector and its magnitude. Its magnitude will be represented. Magnitude of AB vector. So means the position vector of AB. So magnitude of this vector का magnitude अब क्या होगा? So root of b2 minus b1 minus a1 square plus b2 minus a2 square plus b3 minus a3 square. So this will be the length of the magnitude of the vector which is represented by 2 points. So remember these all the discussions. Okay, so how we are going to be adding these 2 vectors, subtraction of these 2 vectors, how we are getting the multiplication by a scalar to a vector, and this will be the vector that, yes, and also we are written here the vector in terms of the vector component of AB point. Yes, it is b1 minus a1 into I, b2 minus b2 into j plus b3 minus a3 into k here, and this is going to be represent its magnitude. So means this is what the representation of a vector between the 2 points here. Okay, so remember this concept. Yes, so this is what the discussion we needed for to solve some examples also. Yes, so remember this point. Well, let us move on examples. So let us understand this all concept with the help of examples. Okay, so here given an example, let A be a example. Let A be a point. So 1 minus 2 and 3. 1 minus 2 and 3. Is there any point in a space? Then there has to be right it in a vector component form. Vector component form. Okay, so this is what the point is given at here. So suppose, so this is what the point. Here we have x and y and z. Somewhere the point is at here. So look, I will help you to. So look, this is what the point is. 1 minus 2 and 3 here. So this is the point O, and this should be as an OP vector. So if I consider this is an P, so OP vector is what? This is R vector. So means the position vector of the point P with respect to the origin, and they ask write it in the vector component form. So vector component form. So vector component of any point x, y, z, how to write? xi plus yj plus zk. So means x, y, z are what? The points which are represented in a space. So similarly here we have x, y, z. So means I write here x is what? Here 1. So means it is I minus 2j plus 3k. So means this is what represents the vector component of the point P of A of 1 minus 2 and 3. Okay, so this is what. I will take another thing here. So what will be the magnitude of this vector? So magnitude means what? We know that vector R is given and its magnitude will be represented by root of x square, y square plus z square. Therefore the magnitude will be what? So root of x square, its value, so means x, it is 1. 1 square plus minus 2 square plus 3 square here. So means totally its value will be, so 1 plus 4 plus 9. So means it is root of 14. So this is what the magnitude of this position vector here. Okay, yes. Let's move on to the next. They provided two vectors. Vector A. So example number 2. Vector A is provided 3i minus 5j plus 9k, and vector B is provided 9i minus 15j plus 2k plus 2k. So these two vectors are given. Then they ask to find out the vector joining the points A and B. So this is what the question is. Okay. Yes. So solution. So let us look at here. A and B are what? These are the position vectors of the points A and B with respect to the origin here. Yes, and they are asked what to find out? Vector which is joining the points A and B. So look, this is what the diagram we have here. So this is the point A and this is the point B, and this is A and this is B. They are asked this vector. Okay, so mean this is what? This is the O, this is vector A and this is vector B here. They are provided here directly vector A and vector B, and we need to calculate vector AB here. Okay, and for that what we know the definition. So AB vector can be represented by B vector minus A vector. Okay, so means B vector is what? Here we have, so it is 9i minus 15j plus 2k. Okay, and similarly minus of, here we have 3i minus 5j plus 9k. So this is what we have. Yes. So next, so now subtract the similar vector components. So means here what we have, 9 minus 3 into I plus minus 15 minus into minus, it is plus 5 into j cap plus, so 2 minus, so what we have, so 2 minus 9 into k cap, so 9 minus 3, it is 6i plus, so here we have plus, here 15 minus, minus 15 plus 5, it is minus 10 into minus 10k, and here we have minus 7k. So this is what the position vector of the points AB, means the vector AB. Yes, okay, and this will be represented by the vector joining the 2 points A and B. Yes, and its magnitude. What will be the magnitude? AB vector, its magnitude will be the root of x square, y square, z square. So means it is 36 plus 100 plus 49. So means this should be what? So here we have a 36 plus 49. So means it is 70, 75 and 75 plus 100. So means 175. So this will be its magnitude also. Okay. So note on this all things.